Good day, my dear students. Today we shall have illustrating hyperbolas given its equation. So we are going to use our graphing application. At this moment, we are going to use GeoGebra. So let's say we're given x squared over 4 minus y squared over 9 equals 1. So all we have to do is to put that in the input tab. So we have x squared over 4. Then we have minus y squared over 9 equals 1. So automatically it gives us the graph of the hyperbola with the given equation. Okay, so now let's start identifying the other characteristics of the given hyperbola. We start from rewriting the equation in standard form. So if we have x squared over 4, that is equivalent to x to the square of x minus 0 over 2 squared minus the square of y minus 0 all over 3 squared equals 1. So from this equation, from the standard form of the equation of the given hyperbola, we can immediately determine that the center is at 0, 0. Okay, then we have a is equal to 2. How did we get that? We can equate a squared equal to 2 squared, then extracting the square roots in both sides, then we will have positive 2. For b, we will have b squared equals to 3 squared. Then we extract the square root in both sides, so we have b equals 3. So let's start plotting the center. Okay, so in the input tab again, we are going to write 0, 0, the ordered pair 0, 0. Okay, here we are. We have the center of the given hyperbola. So from the center, we would be able to determine also the other important points like the vertices. We know that in the equation, we have a equals 2, and a is the distance of the vertex, the vertices from the center. So if we move to the right, then we will have plus 2. We will have to add to the abscissa of the center. Okay, how is that? Since the transverse axis is horizontal, then we will also move horizontally. So moving 2 units to the right, then we would be able to get the point having coordinates to 0. So we have now the vertex at the right of the center. What about the vertex at the left of the center? So going to the left, we are going to deduct 2 units from 0. So that will give us negative 2. So negative 2, 0 would be the other vertex. We can immediately see that the vertex is at these points because these are also the turning points in the graph. Okay. So take note that the vertices are the endpoints of the transverse axis. So we can connect. Let's connect these 2 points. Okay. The vertices having or giving us a length of 4. So therefore, the transverse axis is 4 units long. Now I will be making this broken line so that we can easily see the graph, the main graph of the hyperbola. Now to get the co-vertices, we will take the value of b. b is equal to 3. Now take note that when we have b equals to 3, it means that the co-vertices are 3 units away from the center. So if we will have 3 units from the center, since we have a horizontal transverse axis, then the conjugate axis would be vertical. So we will also move vertically. Now, okay, moving 3 units upward, we will get a point having coordinates 0, positive 3. So we would be able to get the covertex, which is above the center. Now to get the covertex below the center, we have to move downwards 3 units, so that will give us a point having 0, negative 3. So these are the covertices of the given hyperbola. Now connecting the 2 points, the covertices, we would be able to form a segment that is 6 units long. That means that the covertex, that means that the conjugate axis is 6 units long. Again, I'm going to use broken lines so that we can easily determine the actual graph of our hyperbola. Now, from these points, we can also make the auxiliary rectangle or the central angle. Take note that the sides of the auxiliary rectangle are congruent to the transverse and conjugate axis respectively. So we make a polygon, a rectangle in particular, okay, by putting this vertices of the polygon. Okay, so we were able to make a rectangle having sides which are congruent to the transverse and conjugate axis. So this is now our auxiliary rectangle or the central angle. Now to make the asymptotes or to graph the asymptotes, we are going to click line, then connecting the non-consecutive vertices of the auxiliary rectangle, then we would be able to make the auxiliary rectangle. Okay, so connecting the 2 vertices. Okay, that's it. Now we also do the same to the other vertex of the rectangle. So we were able to form the X lines. So we have the asymptotes of the given hyperbola, having an equation of negative 3x plus 2y equals 0 and 3x plus 2y equals 0. Now we're down to determining the focus of the given hyperbola. Now, in order to get the coordinates of the focus, we're going to get the value of c. We know that c is equal to the square root of a squared plus b squared. So c is equal to the square root of a squared plus b squared. Substituting the value of a, that is 2 squared. Okay, then it will, for b, we will have 3. Okay, we will have 3, then it will become 3 squared. Simplifying this, we will have square root of 4 plus 9. Adding 4 and 9, that will give you 13. Now converting this to decimal form, it is approximately equal to 3.61. Okay, so that means the foci are 3.61 units away from the center. Okay, so in order to plot the foci, we can just type in in the input tab, okay, 3.61, 0, okay, so that is for the foci at the right. Now for the foci of the focus at the right of the center. Now for the focus at the left of the center, we will subtract from the abscissa 3.61, so 0 minus 3.61, that will give you negative 3.61. Okay, then we just copy the ordinate of the center. Again, why did we change the abscissa, or we have added 3.61 to the abscissa? Because the transverse axis is horizontal, and take note that the foci, the vertices, and the center are collinear, and the transverse axis connects the vertices of the hyperbola. Okay, now we're next to what's next to do is to get the latus rectum. Take note that the length of the latus rectum is given by the expression, okay, 2b squared, okay, 2b squared over a, okay, so 2b squared over a. Now substituting, then we will have 2 times 3 squared over 2. Simplifying, we can cancel out 2. So 2 divided by 2, that is 1. 2 divided by 2, 1. Simplifying further, then we will have 9. That means that the length of the latus rectum is 9 units. Now, how can we draw or graph the latus rectum? Take note that the latus rectum is the latus rectum passes through, okay, passes through the focus. So let's plot, okay, let's plot the 2 points being connected by the latus rectum. So here, okay, I will plot a point on the hyperbola, okay. Then I'll connect that point to, okay, we will connect 2 points on the parabola, hyperbola rather. Okay, so since, take note, the length is 9.01, that means we need to adjust to make it 9. Okay, so let's form the other latus rectum. Okay, I'll clear first the annotation so that we can clearly see, okay, the graph. Okay, so we will connect again, or we can construct a segment, okay, connecting 2 points, okay, connecting 2 points on the graph. Okay, so then take a look at this, okay. Then we will just adjust, okay, to make it accurate. Okay, it should be equal to 9. Okay, so here we have the latus rectum of the hyperbola. Okay, so if you want to get the endpoints, all you have to do is to get the coordinates of the endpoints of the hyperbola. Okay, when we have x is equal to 3.621. That's all for today. I hope you were able to understand the lesson for this day. Thank you.